I'll start by introduction. Hello, everyone. Welcome to today's Luohan Webinar. I'm Verena, the host of today's event. I'm a faculty member currently at Nanyang Technological University and a research fellow at Luohan Academy. It's my pleasure to introduce our speaker, Professor Joshua Gans, who's the Professor of Strategic Management and Jeffrey School Chair of Technical Innovation and Entrepreneurship at Rotman School of Management, University of Toronto. Joshua is also Chief Economist of the Creative Destruction Lab and a Distinguished Fellow of Luohan Academy. Joshua is a leading voice on technological innovation, which brings us to his timely talk today on how AI adoption is impacting scientific research. And I look forward to how this talk would reshape our understanding of the knowledge production process and its policy implications. The audience are welcome to unmute themselves and ask questions during the talk. I'm sure this will be a fascinating discussion. And with that, I will turn it over to you, Joshua. You have 1 hour and the floor is yours.
Great. Thank you so much, Verena. And thank you, everybody, for tuning in today. I know most of you, it's night. Having some economic theory before bed is a treacherous thing to do. And so I appreciate it. The topic for my talk today is on artificial intelligence. It is basically something that we've been working on, an area I've been working on since before it was fashionable. And in recent times, so this talk is interesting for a couple of reasons. One, of course, it's going to be studying an aspect of AI. The other is the work that I showed you presenting here is part of a set of research that I've been doing for the last 6 months in terms of how I write papers, which we'll call AI first. In other words, I start with using a large language model, and it changes over time because these things have been evolving, and I use that to help me write the paper. I've learned a lot from that process. It's not a necessarily a very simple one. There's actually all sorts of interesting things you learn about yourself, and you learn about these models as well. But I'm absolutely convinced that in terms of being able to produce theory more basically quicker, for want of a better term, it's quite unparalleled. If I hadn't told you that, you wouldn't notice anything here with that regard to that, but I thought that might be of interest. Okay, so this paper is called A Quest for AI Knowledge. And the research question is a very simple one. It's going to focus on AI adoption and how that will change the production of knowledge. By which we mean research, and research that is generally more applied. So there's been a bit of work that's looked previously at the supply side of this. But I'm really looking at the demand side. What does the use of AI do to how people actually change the direction of research, basically? And the supply side has sort of been was handled. There was a conference that we held in Toronto back in 2018 on the economics of artificial intelligence research agenda. And we invited a whole lot of people to contribute to that. And one paper that came out was by Coburn, Henderson, and Stern, which looked at artificial intelligence as being a shift in an innovation in the method of innovating. So it was a tool that would accelerate innovation. So that's what I mean by supply side. And a version of that was by my co-author Ajay Agrawal with Mikhail and Otto on how AI might improve the research process by improving basically search for interesting combinations of useful ideas. So those are examples of supply side thoughts on how AI will transform research and science. Um, by contrast here, so I'm interested, and I've always been interested in how knowledge itself is translated into better decision making. Our book Prediction Machines was all about that, and that's been a focus. And I have a book forthcoming from MIT Press, The Microeconomics of Artificial Intelligence, which places that front and center as well. But really what you have is in that process is AI comes along and it sits between the knowledge and the decision making. That is, AI is a tool to improve decision making by improving baseline knowledge, whether it be sensors from a car or data or directly or anything like that, and how it leads into decision making. And AI is a prediction machine, prediction technology, that allows you to more appropriately access the knowledge you need from the knowledge you have. And so that's where this project is going to focus. Um, in particular, oops. So the research question sort of narrowed down is how will AI adoption change the knowledge that is produced? Uh, and I've thought, there's been some work on this sort of thing about how AI will change the incentives of users who are providing data that was feeding the AI. And so this is not going to be that. I've written a paper on that, but there's some interesting social and other aspects and public good aspects to that I'm not going to be dealing with. Instead, I want to think about research as we normally think about it, producing a new knowledge point and producing a new knowledge point that will lead to, in combination with the rest of knowledge, to better outcomes, in this case, decision making. And in order for that to occur, you have to have a model of knowledge for decision making. Okay. Fortunately, one appeared. And it was this paper by Carnell and Schneider that was published a few months ago in Econometrica. And it's called A Quest for Knowledge. You'll notice that the title of my paper is A Quest for AI Knowledge, which is basically saying, and I know that's not fashionable these days to say you're building on the research of others, but I am, and I'm happy to say it. And basically what the research question I took in its narrowest, what it evolved to was, I wonder what happens if I take their model and I add an AI element to it. And for reasons that I'll explain, that's a sorry, that's a thing that you can quite naturally do. Their paper is actually quite involved, and so it took me quite a bit of time, even with the help of AI, in order to absorb it. So much so that, but I love this paper. And I've built several papers off of it thus far, which you've seen one or two today. Um, so I wrote this paper, A Simplified Quest for Knowledge, which you can get from my website that I put into the chat, that it provides a much easier way of entering and understanding their model, in my opinion. So, it's very good, and I highly recommend this model and learning to understand it. So let me try and explain what they do first. So what they do is there's a universe of questions represented by a number on the real line, and each actually has a unique answer, y of x. Y of x is uncertain. You wouldn't know it ex ante, but it's the realization of a Brownian motion of a random variable, big Yx, or what we'll call the truth. So in other words, you get a series of questions, they have an answer, and what you're trying to do is infer what the right answer is. Um, Existing knowledge is represented by the list of question and answer pairs that have already been discovered. and answered. And so you have a list, and you can index them by the list of questions, X1, X2, etc., on the real line. Why is that useful? So a new point, we'll call it XL, gives a few things. It gives precise knowledge to answer the question XL. So you have an answer to that question if you've got already an existing point. But it also, if you look at this thing, figure 1 here, which is from Cornell and Schneider, on the left-hand side of it, shows what happens if there's a single knowledge point, XR. When there's XR, you can see that squiggly line there. That's the Brownian motion of answers. Now, why is that significant? Is right at the point XR, which is an existing knowledge point, you have no uncertainty. You know what the answer is because you've discovered it previously. But it's also the case, because it's a Brownian motion, that questions that are close to XR have similar sorts of answers that can be predicted from the knowledge point XR. And so you can see there, the squiggly line's the Brownian motion. The dotted line are the confidence intervals that you would have on making, on forecasting what the answer would be for things to the left and right of XR. So when you get a new knowledge point, say XL, which is to the left of XR, that gives you a precise answer to that question. That's the whole definition of it. To the left of XR, you've got some conjectures. To the right, to the left of XL, you've got some conjectures. To the right of XR, you've got some conjectures. Obviously, there's nothing to the right of XR has changed as a result of this new knowledge. That's a function of the Brownian motion assumption. But between XL and XR, you can combine those two knowledge points, and you can get a more precise answer to questions between XL and XR. So the value of knowledge is that it allows you to improve the set of conjectures, both to the left of XL and between XL and XR. That's what the value of knowledge is. It does these things. So it's a very neat way of expressing the value of knowledge in decision making, as I'll just show. So the conjecture is a distribution of answers to any specific question. The Brownian motion determines answers. Their conjectures are normal distribution, which makes it easy to deal with. Existing knowledge determines the mean and the variance of those conjectures. So for a question, say X in between Xi and Xi plus 1, two knowledge points that are adjacent, or Xi plus big X, which is the sort of interval, the interval or measure between those two knowledge points. And D, which is sort of the shortest point between any given knowledge point and a boundary. You can quite easily determine the variance of these conjectures by the formula at the bottom of the slide there. Again, it makes it, you'll see, quite easy to deal with. So how do you deal with it? What do you want to do with all this? For each question, so a decision maker is someone who gets asked a question and has to decide whether to take an action on the basis of that or to not do anything. So if they don't take any action at all, they earn 0. They're sort of outside payoff. If they do take an action, they earn 1 if they know the correct answer and can match the action to that answer. They get 1 minus this quadratic loss if their conjecture is further away from the action that they take. So obviously, if they could know the conjecture yx, they would like to take an action equal to that. If they don't know it, the best action that they can take, if they're going to take an action, is to, because it's a normal distribution, take an optimal action that's equal to the mean of the conjectures for that particular question. Which means that you get an expected payoff of 1 minus the variance at that point, divided by Q, and Q is a measure of the stakes and other things that could be there. Notably, if Q is very high, very small, you might choose not to take an action at all. Okay. So it's a very neat structure. So what's the value of knowledge? The value of knowledge is such that you only act if the variance is less than Q. So Q has to be high enough for it to be worth acting. And of course, that relates to the variance, which relates to the knowledge points. So if you're adding a new piece of knowledge, you've got to think about all the questions and decisions that it could impact on.
Can I interrupt for a moment?
Yeah.
I have a question. How do you define the proximity of the questions? You mean you change some words in the question, and then because the words you changed are only a small part of the question, then they are very similar, near to each other?
Well, as usual with economic theory, we put it in there, the set of questions, and codify them on the real line, which has a natural ordering that we assume in terms of closeness. That's sort of part and parcel of the Brownian motion. So technically, closeness means that if your two questions are close to each other, they're likely to have a similar sort of answer. And so you can imagine, you know, the might not change at all if the color of something is red versus blue or something like that. But, you know, strictly speaking, of course, it's hard to translate this into a language or other things. So this is just a knowledge representation. I do know, in case you're wondering about it, but nothing I'm going to tell you changes if we, for instance, have two-dimensional knowledge, question space and knowledge space with Brownian motion designed. I worked it out, nothing changed, and then I had to abandon that was that. So yeah, so just think about this as a representation, exactly explaining which bits of it what is a whole other matter. Okay, so if we're thinking about incentives to create knowledge, we have to think about what a new piece of knowledge would do to the overall value, the overall quality of decision making. And so that's this integral function here. The integral function is the expected value you're going to get from decisions based on current knowledge. The benefits of a discovery is if I discover a new point X and YX, this pair of questions and answers, how much will that increase that that expectation? No, that aggregate. So there are kind of what's the Carnell and Schneider thing does something very interesting. It says there's sort of two ways that we might be interested in how knowledge changes. The first is if you've got sort of X1 and XK that are sort of in the frontiers of knowledge, you could expand knowledge by finding and searching for answers to questions that are outside of this interval X1, XK. We'll call that expanding knowledge. You can also deepen knowledge by finding new knowledge points inside that interval. Obviously, if X1 and XK are a long way apart and they're the only two pieces of knowledge, there's not a lot of difference between expanding knowledge and deepening knowledge. But there are situations in which those things are different. And so what Carnell and Schneider are interested in is when researchers would choose to expand versus deepen knowledge and the conditions for that. And I'm interested in that too, except I'm going to put a wrinkle on it, on all of that. So think about the impact of a discovery. Here we plot the expected payoff for each question that you'd get if the only knowledge point we had was on the left there, X0. And you'll notice it's a linear pyramid triangle. Exactly X0, you can get a payoff at 1. As you move further away, it declines linearly until such point it gets to 0 and you choose not to take an action at all. If you add a new knowledge point X1, there, you'll notice that sort of splits the two edges of the triangle in two, and then puts a loopy thing in the middle. A loopy thing is a formal term for a thing that goes down and then up in a curvature. Not formally defined in the paper, but you'll be surprised how much when you're chatting with AI, how much it likes those sorts of terms. But that's another matter. So you can see there's an interesting thing that occurs when X0 and X1 are both available, is that in the middle there, you can do quite well by using both pieces of knowledge in order to come up with a conjecture, come up with a better mean, and make a technically better decision. Obviously, it's minimized at the midpoint between X0 and X1 in that sense. So that would be the greatest value of a point where you could improve knowledge if you could find an answer to it. One interesting thing you might face if you started off with X0 is where would you choose X1 to be if you were researching? If you choose them too far apart, you miss in the middle some of the values of being able to interpolate between them. So that is not something you do. If you do it too much close together, you sort of, maybe there's some other benefits you can get, but here at this one on the right hand side, it's sort of this is sort of just right. If you put X0 and X1 sort of at a certain distance from each other, it turns out to be 3Q. You'll get this situation where you'll activate all decisions in between them, although you're not doing much better at the midpoint than you were previously. So these are the sorts of trade-offs. In other words, you have to think about how far your current knowledge is from the knowledge you're researching in from current knowledge to think about the value it will have for decision makers. So the researcher's choice is to choose a distance between a new knowledge point that is a distance d from the existing nearest knowledge point. So deepening, it's often optimal for you to choose between the midpoint there, because you'll get the biggest kick in terms of the value of what it can do for a decision making. When you're expanding, it turns out to be optimal to choose a distance of 3Q. But the researcher's objective, so the researcher objective is basically a couple of things. They care actually about improving decisions. I know that's potentially a controversial assumption, but we're assuming they're sort of socially minded within their space. But the second thing that Carnell and Schneider have is if you choose to research for a given knowledge point, it's not certain you'll succeed. And the probability of success is rho. And the cost of research is basically the further you research from existing knowledge points, the less likely you are to discover something, which is quite natural. And so that's captured by that second term there in the payoff of the researcher. Obviously, that's indexed by eta, so the eta, the longer is eta, the more more costly it'll be to research further away in terms of sacrificing the probability of success. Again, this is all from Carnell and Schneider. I've literally done in half the talk is advertising for them, but that's okay. It becomes relatively easy to do my bit after this. So researcher choice, if you had X1 and X2 and X3 as an existing knowledge point, you can either deepen or you can expand. The values for those are given right here. And more importantly, there exists a threshold of the sort of space between two knowledge points, such that the scientists expand knowledge if and only if all bounded areas have a length of less than a certain amount. So if two knowledge points are far enough apart, you'll research in the middle of them because you get some benefit. If they're very, very close and knowledge is very dense, then that'll push you in your direction of research to expanding knowledge. So you can imagine a process by which that might evolve in an interesting way. So out to my paper. I'm going to do two. This was all worth it, by the way, because this is something I have to. I'm standing on the shoulders of these guys, so I had to give you what I needed from their paper to do mine. So let's talk about AI. What AI is good at? AI as tools, as prediction technology, are good at interpolating and extracting their answers from existing knowledge. If you can say, this is why, you can ask it to write a song in the style of Taylor Swift about another subject, such as electric vehicles. It knows both of those things, and combining them is something that it can do. So the same would be true of any two knowledge points. There's very, very well if you can tell it which knowledge you're trying to combine and see the differences between the two. But it's not very good at generating questions beyond the knowledge frontier. Apparently, in a year's time, I'm supposed to eat my words on that. But, at the moment, right now, at the time of writing this paper, we're yet to see things that would consistently be regarded as solid expansions of knowledge. They seem to be more at interpolating. Now, so if you accept that that's what AI is good at, so that's basically the premise here. And as I said, I think there are good arguments for that, and there are good ways of thinking why that would be the case. What if such AI is adopted? Will decision makers adopt AI? And if so, what would that end up doing to the research for the knowledge points that are now not being fed fully for human decision makers? They're now being written for AI. You're now written for AI that will use them and then help the humans make decisions. So I'm going to make a very simple assumption right now, is that within a bounds of a length XA, if there are two knowledge points within that bounds, then AI can make the decision perfect. So it's illustrated by this diagram. Here, XA is outside of X1 and X0 and X1. And that means that it's the decision that it can do anywhere between X0 and X1, not over XA, which is bigger. X0 and X1 is now perfect. You get a payoff of 1/4. So obviously the AI is great. This is definitely an AI is great paper. But obviously it's not going to work if XA was too narrow and it didn't bridge two existing knowledge points. It can't do anything. So it has to be expanded between two knowledge points. And then to anticipate, it may be that that AI has a certain capacity and that current knowledge doesn't span it, but that's going to change your incentives to produce knowledge that will span it. So what does that mean? So that means now if we adopt AI, it's going to change the value of decision making. For expanding, for both expanding and deepening, if XA is able to bridge two knowledge points, these now become the payoffs. But here's the important thing, is remember, from the point of researchers are caring about the quality of decision making. And so if XA has increased, that means, so previously when I wanted to choose a distance that was higher from an existing, greater from an existing knowledge point, I'd face this trade-off. I are able to activate more decisions, but the decisions within the bounds of the new distance start to get worse and worse. So that's the inframarginal trade-off. What AI has done is, if those two knowledge points were within AI capacity, there's no inframarginal trade-off anymore. And if there's no inframarginal trade-off, obviously my incentives to produce research that can push all the way to the boundary of AI capability, because why do anything less, have increased. So these are very strong complements here. Increase XA by a bit, and it will correspondingly lead to under some conditions that I'll get to in a second, increase the research distance. So it's as if every improvement of AI improves the novelty of research, improves the incentive to produce more novel research. But that has a wrinkle to it, and it's this. So if I'm going to plot XA against the distance chosen by the researcher. And D star there is the representation of the distance the researcher would choose without AI. Now, notice, obviously, as XAI increases, initially it's sort of too low for the decision makers for the researchers to change their profiles. But then you hit a point, a threshold, which all of a sudden it becomes worthwhile to do that, and worthwhile to match your research distance with the capabilities of the AI. And as you increase XA, you increase your research distance correspondingly because there's no inframarginal cost anymore. That's the strong complementarity. But notice that kicks in. That can kick in earlier than your current research distance choices. So that means that as we increase XA, the capabilities of AI, we start to influence researchers to match that. But matching that could mean actually reducing the novelty of their research. And then as XA increases after that, there's an increase in novelty. So increasing AI capacity increases novelty. That's the effect that it's got. But that process could start at an earlier point. So a researcher now would choose a less novel research productivity, the research novelty, at a point that may well be lower than the novelty that they're choosing. Okay, so in other words, there's if you care about that, what is the impact of AI capabilities on research novelty? Initially, it might be negative, but then it's always eventually will lead to an equilibrium with higher research novelty as AI improves. However, regardless, and this is very important, it is always welfare improving to have AI available. So AI, even if it does lead to a reduction in research novelty, that is optimal. You actually didn't want as much there. So when you had AI, you want to utilize it, and that's the gain you get. So it's the main result of the paper. Everything follows from this point onwards. In many respects, as I said, because of the process of this, it's not as surprising as it's not necessarily surprising because the intuition is so strong. But you get some interesting situations when you try to apply the model. For instance, one thing you might be interested in doing is you have a single point of knowledge, seeing how AI would change the evolution from that. And obviously AI is going to change the evolution because you're going to match AI capacity to drive how much you evolve. You'll continue doing so because you will always be able to extend any 2 points within existing capacity so they can interpolate between any of those 2 points. You don't get any like research cycles because everything has a very strict stepping stone length going on. But nonetheless, that's a very interesting thing that occurs. In fact, it's so interesting. I'm going to show you what I did with that in a second. You can get research cycles. Carnell and Schneider spent a lot of time on this idea that you might intervene a little bit to kickstart research. For instance, what you might want to do is you want to have a moonshot, a thing way outside the knowledge frontier, so that researchers will be motivated to fill in knowledge deepen after that until it gets dense again, in which case you got to kick it out again and research further. And so we could have that where you've got an initial configuration here that was, say, 3 times capacity. Well, the first thing a researcher wants to do is produce a new point so that you can start utilizing the AI. And then the second thing that they'll want to do is deepen between x0 plus xi and x1 so that they can get a twofer. When you deepen, you can use AI going either direction with a single knowledge point. So it really, really kicks in that complementarity there. And then after that point, you will expand further. So you get these sort of interesting things that could occur. How these might manifest themselves empirically might be on terms of, how researchers research for the AI to fill in these gaps within AI capabilities. And that would be something that I don't know how we'll do it. Someone will dream up how to do it in the future. As I said, AI is novelty promoting and welfare improving. I think I've already just mentioned that, so I'll skip. Okay, this stepping stone thing gave me an idea. It's like, that seems very balanced. And you know what? We like to be balanced? Growth. We probably like them to be balanced normally, but we definitely like to be balanced from a modeling perspective. So I wrote a follow-on paper very recently called A Growth in AI Knowledge. And I've just got to run through because I can. Now that you've understood the basics of this setup, I can sort of describe to you how this works in a growth framework. And the reason for doing that is you can do something that Carnell and Schneider had some trouble with, which was how to do welfare calculations, how to do welfare results. So in this paper actually has two contributions. One, it translates Carnell and Schneider into a growth framework, which is very far removed from their thing. And then it also says what happens when we have AI of the sort we've just been talking about. So this is a full-on general equilibrium model. But now in growth models, production is normally a function of the performance on a number of tasks. Tasks, decisions, close enough. So let's call those the production functions a whole lot of decisions as applied to by labor, who make those decisions and operationalize them. Labor is scarce. That's the second equation. So what happens in terms of research in this model? Research is going to improve is going to change the set of decisions. That's what we've already talked about here. It changes the set of decisions. It changes the quality of decisions. So let's do that. So the research is going to research. Now they're interested not just in maximizing the value of decision-making standalone, but now they're interested in maximizing the value of decision-making in production as utilizing the scarce labor. But other than that, it looks very much like our existing Carnell-Schneider model. Research productivity itself, as you would do in a growth model, is going to, so the researchers are going to do two things. They're going to research, but they're going to need some resources. They need people, and they also need research capital. So lambda t is the research productivity, which is basically the probability that the project succeeds. And it's a function of capital, labor, and also past knowledge as represented by the set of tasks that can be activated. That's going to turn out to be quite interesting. Growth is the increment in an actual number of tasks that are enabled by new knowledge. Which is lambda t d star. And then there's this interesting variable called knowledge density, which is basically how, if you look at the current set of knowledge, how sparse or deep or dense is it? So that's going to be something that matters as well. So I'm not going to go through the details of this, but we get a balanced growth path for both the scope of knowledge, number of tasks, n, and also output that are given by these equations here, where lambda and beta are coefficients on research productivity and actual productivity respectively, and alpha d star is a measure of the sparsity of past knowledge. The question is, what is alpha? Well, that sort of depends on your view. There's a view out there that having more novel knowledge is more productive for research, in which case alpha would be greater than 0. Or there is another view, which, anyone who does sort of statistic work, econometrics, likes, is denser knowledge is more productive, in which case alpha is less than 0. And that turns out that drives fully the social outcomes in this model. If novelty is what is productive, then the knowledge chosen by private researchers in this model, even though they're caring about impact on production, at least in the short run, is less than the social optimum. If alpha is less than 0, private is greater than the social optimum. So you get this. This has nothing to do with AI, just an interesting thing going on here. But what happens, therefore, when you produce AI? Well, I'm going to model in the paper. I model a little differently than the Stark model in the first paper. I just assume that AI, if it's within the capacity that's relevant, will reduce by some amount the variance of the decisions being taken within the scope of AI. So it's going to reduce the variance. So it's increasing quality that way. That's the same trade-off as occurring, just a little bit smoother. So with AI, you get a similar sort of outcome. So AI doesn't actually directly impact the growth rate. That's happens in these balanced growth models all the time. But it does increase change incentives for research. And so, as we've already said, it will increase them. It'll be distance increases with AI. And so if it turns out that novelty is productive, then AI will increase research novelty, and that will be great compared to what we've currently got going on in terms of that. If density is productive, AI is going to be working against that because it drives more novel research. And so it's going to have a different welfare effect in that regard. And so I just want to mention one more thing. Sorry, I missed it. Didn't mention this. In this model, it is assumed that AI is provided by a monopoly firm and priced in, and that helps drive adoption as well. If I had a lot of time, I would love to show you the mechanical details of how I arrive at that thing at the bottom there. I don't know how to show this AI price because it was quite fun. But anyway, but that means that, the quality of the AI impacts on what the AI provider can get, etc. So that allows me to do a ton of stuff policy-wise. For instance, competitive AI provision. Suppose it wasn't a monopoly, then you can show that you get more novel research with AI than under an AI monopoly. Is that a good thing? Depends on alpha. You might not have wanted more novel research. If you regulate AI safety, you say that AI can be used, but it has to have a minimal standard. In that situation, you might decide not to adopt AI at all. Because you would have used it if it was worse. But now that you've got to do a minimum standard you want, so that has effects as well. And then finally, of course, we can, at the moment, we've got researchers researching and then just handing their knowledge over to the world. What if they license their research to an AI provider? And basically, you can show that high AI capability implies low open licensing will promote more research than proprietary licensing. And so you can do some of those predictions from this as well. So I've gone through this in record time because I was allowing for questions, but I guess we haven't had any. That's all, which is fine. And I'm certainly happy to elaborate on anything. But where this research agenda gets us is that The first finding is that AI tool capabilities are highly complementary with knowledge expansion. As AI tools improve, more novel knowledge will be produced, but only in the long run. There could be an initial decline in that. The social welfare of all that depends on what type of knowledge scope enhances research productivity, which is an open question, and I don't know actually the best way to assume it. I got in the paper a couple of micro foundations saying it could go this way or that way, depend on network embeddedness or your desire for combinatorial research and things like that. But there's nothing definitive there. And that, so future directions, just where is this all going? I want to think about how AI decision-making tools interact with other AI tools. So not just the adoption one, but ones that are impacting research directly. How does AI impact on the cognitive division of labor and knowledge production within a firm? And I've got a paper that I'm working on in that regard. It turns out in quite interesting ways that it could impact on how firms evolve and compete and other things like that. And another set of research that I've got with Avi Goldfarb and Ajay Agarwal is on the impact of transformational AI. And we're very, very interested in how Dario Modi from Anthropic's forecast that we'll have a data center full of geniuses will impact on the knowledge economy. Because one thing this research shows here is, yeah, you can have a data center full of geniuses, but it's not obvious that the demand for geniuses is there. I know that sounds funny because we tend to think that that's the case, but you know, we already don't employ all of our geniuses necessarily now where they should be. And it's not clear that we would do the same with AI. That would require us understanding what the demand for geniuses normally looks like and what drives it. So that's an open question as well. And that is where I got to. So I guess my AI generated research has also sped up my talk, which may not be a good thing. So please ask some questions if you've got have any.
Hi, Josh.
Hi,
This is Long Chen.
how's it going?
Yeah, good. Great to see you here. One second. Can you hear me?
Yes.
Okay. I have a sequence of questions. I'm saving this to the end. Try not to disrupt you. I'm trying to understand this paper in the big picture of whether AI is promoting efficiency or innovation. And I think that's in the big picture of the one we have to redefine knowledge worker. We do know that that's happening in every industry.
Right.
Now, and I was saying that humans are left for something machines could not do much. And for example, so I think that's a big picture question. So one insight, I think you can tell me I'm right or not. I think you're trying to say that AI is a special in the sense that it's very good within the knowledge domain, and exceed that the costs just go up a lot. It's not continuous at this stage. I think that makes this thing unique. But my question here is that isn't that so? My first question is that human beings also the same? We are good at remembering things, repeating things.
Right.
But not so good for innovation. So it just match us well. I mean,
Yes.
so some of the AI will just help us to improve efficiency. And some of that can do better. So that's human beings are like this too, discontinuous. That's my first question.
I can let me answer that one. So in the model, Carnell and Schneider sort of get this effect already, that decision making is better when you're interpolating than when you're going outside, which then also changes your incentive of what knowledge you create. So basically all the AI is in this model is within that domain. So it's an asymmetry, a better decision making, a better tool. But it's better to use AI than just rely solely on humans. So, of course, nothing I've done here that says there isn't a human still required for that or anything like that. The growth model actually explicitly has all that still occurring, and it directly, it's a tool that enhances the productivity of humans. But in the knowledge space, this is sort of the interesting question, is sort of like there is a lot of discussion going on about whether, you know, AIs will be much better at research and creative and all those things than people. And maybe that will be the case in the future. My argument now is with the AIs that we have that are currently based on machine learning,
Right.
their improvements are statistical. And, you know, we tend not to use statistics to expand our knowledge domains, you know, our expand beyond existing domains. You know, out of scope predictions are hard and things like that. So what I'm saying is, well, if that's the case, what is this impact going to be? And to do that, you know, and so that turns out to be a more an interesting question to ask. But if you then translate, if you say, oh, I object to that, I think AI is going to get better at everything. Well, I can't make any predictions then. Can't do anything nuanced. So, you know, if the world doesn't look like I presented this model of what I'm expecting. You can have an alternative model that might be more dramatic, but you'd probably be able to empirically disentangle that. So you have to kind of have both theories for that. But I actually think what you're talking about is very interesting in terms of knowledge within the firm, which is my current thing that I'm working on, this cognitive division of labor. So currently, models of knowledge in the firm assume that workers come in and they've got knowledge, and which workers with which knowledge do you hire, and how do they talk to each other, and things like that. Whereas I'm actually interested in, let's do it stark. Imagine you've got workers who can use existing knowledge and use it statistically. And then you've got other workers who can actually, you know, they take existing knowledge, but they can also, you know, with a bit of effort, work out the answers to the questions around that knowledge. What's the division of labor between those? And I have an answer for that, and that can be maybe next year we'll come back and do that. But I think that's the fascinating thing here. And, you know, when you're thinking about it sort of forces you to think not just about the knowledge that people have, but their skills in how they can use knowledge, how they can
Yeah.
make use of it. And I think there are real differences there that well, I know of no economic model that's looked at it. And then, of course, AI in that context is interesting as well.
So there's a related question of what is knowledge innovation. So how much of that is like a prompt innovation plus a good use of tools?
Right.
How much of that is just the efficient prompt efficiency? So I think it's, to me, just like Ben Holmstrom talked the other day at our seminar, basically 90% of the time for a PhD is to propose the right question.
Yes.
Find the right question.
100%.
And if the prompt is the key, then I think a lot of that, so the AI can be very useful because human provides the best prompt.
Right.
Even given the current capacity, then that guy just generates stuff, a book, a paper for you within hours.
So here's a case where I think that framing the question in that way is misleading. In my experience now, is that it's very easy because we sort of think about how we deal with PhD students and stuff like that, but we actually should think deeply about that. So there is certainly an element of thinking human superiority in coming up with the right prompt. Or for starters, no, the AI isn't sitting around waiting for something to do. It is sitting around, and then you have to tell it. So you have to start it off somewhere. But I have to tell you, it's not the AI. The way I would think about AI now is as a moderately competent but unreliable research assistant. And unreliable in a certain sense. It's very reliable in sort of getting things done as quickly as possible. So that's good. It's very useful that way. So you can actually have a conversation. You can do quite some calculations and things that can be could be quite time consuming, or straight out research. And that is really helpful because you can actually the cadence of this dramatically increases. At the same time, the things it tells you in answers to prompts, even well-structured ones, can be hopelessly off base. And at the moment, I know I have a skill that I'm even still developing, but I had some baseline to be able to notice when that's wrong. It's very tempting because it looks good. The answers to rely on it. You really have to do it. I have 6 months learning how to do that process. So it's like learning when your student is good and when it is not, in terms of all right. The second part is sort of like in the direction of the conversation. You think, oh yeah, the humans come up with the prompts. Quite, because you sometimes have conversations saying, I'm kind of stuck here. Can you give me some options? And even if none of the options are good, that helps you craft a new prompt that starts to get some better stuff. So it's not black and white. It really is a cognitive tool that works with you. It's just, and the better it gets, the better it will be at that. While fundamentally the ideas are coming from us, a few things that I've had conversations with AI in, if that was a human, that process has led to improvements, and I would be starting to think of this student should be a co-author rather than, but of course it's a machine, so it doesn't matter. But you know what I mean? It's like that. In other words, I can't tell you, where in the ether of my interactions this thing came up.
I have a last question, but so I'm trying to push for a clear conclusion of the paper, in my understanding.
Right.
And I'm worried, I'm a little bit concerned that it's really based on the current capacity of AI. And you see, earlier on, before the coming out of these reasoning models, then we thought then that guy is really as discontinuous, I think. Then we have the chain of thoughts reasoning models. Now it becomes more complicated, and we can see this evolving very fast. So what exactly are you trying to predict? If you are trying to say for the current capacity, it can only do this, that of course makes sense. But maybe in the next a year, after a year, this guy will make you become a co-pilot and rather than this guy.
No, not quite.
So I'm trying to see your key message.
Yeah. The reasoning models, as I said, the last thing about reasoning models are hugely important. But let's be very clear. Reasoning models are just AIs prompting themselves, prompting and answering themselves. And sometimes they go way off.
That's
but
true.
Still underlying there is still a statistical process, and even more so because those prompts have to be sort of based in some statistical thing that's improving the token to them, pushing it up. It is even more so that I think that they're interpolating existing things. This is why, these ideas that they're going to come out with a completely novel proof aren't the same way. The only other way this has occurred, the only novelty that we've seen has occurred in Go. We saw some true things that we regarded as novelty. Why did that happen? Well, that's reinforcement learning. It just is searching a much bigger space, but also had the ability to notice when something was when it was a good move to make. That people hadn't thing. That's closest we've had to sort of like discovery outside our knowledge domain. But even that was in a space that we already had the rules and the knowledge and the structure to perform that statistics. We just didn't have the capacity. And then also, once it discovered what is move 37 or what it was, then people studied it, and that changed the name of Go. So, you know, is that a new knowledge point? Yes, for the humans. How was that discovered? Through the statistical process in an environment that is already in a limited knowledge domain, actually. So, you know, I don't know. You know, would be overjoyed if AI can do new things. But I'm telling you, right from what I've seen now, AI can give you ideas that other people have thought of for sure. Coming out with like a out of the box thing, and I spend 4 or 5 hours a day on a work day talking with things. I haven't experienced it yet. Even, you know, wow, that
Yeah.
the stuff is far more routine, and I think there's a reason for it, because ultimately the problem with the prediction machine is it's an averaging machine.
Yeah.
That's what
I
these
think
things do.
that's what
Yeah,
I learned from you most today is that it doesn't matter whether it's the pre-trained model or the reasoning model, it's still within a domain.
that's right.
So
That's right.
it has the domain of what it can do. So
Yeah.
anyway, I will stop here.
Yeah, reasoning models work precisely because they're in the domain.
Got it.
Right.
Got it. Maybe somebody else has questions. I'm sorry.
Uh,
I think
in light of the time, so there are questions from the chat box. Joshua,
yeah.
you might have like a very short answer to that.
I think I
Tell me
answered
what
some of these in this thing. Distribution of wealth, I don't yet I don't have an answer for, so I won't be able to tell you anything on that from this line of research. And I think we talked about creativity just with Long at the moment. Yeah.
Perfect. So for the time's sake, it's a fascinating discussion today, and I learned a lot. Thank you so much, Joshua, for joining us today. If anyone gets any question, please feel free to email Joshua or Luohan Academy directly. Thank you so much, everyone, for attending today's talk.
Thanks very much, everyone.
Thanks, Josh.